Okay, girls, upon further consideration, I thought we could do these two sections at the same time. So there's two kinds of different things here. One of them is a table, one of them is a tree, and we need to talk about a couple things. So we're going to talk about two events happening at the same time. I'm going to kind of break this page up into the table side and the tree side, and so we'll do both for each. The first question here says box A and B contain 4 counters each. Box A contains 2 red and 2 green, and box B contains 1 red and 3 green. And then a single counter is selected. So two things are happening. I'm picking a box, and then I'm picking a counter. So the first thing I'm going to do is try this table idea that we talked about. Side, and this side I'm going to have the counter side. So I might have box A and box B, and over here I might have red and I might have green, and then I'll total up to see if everything's okay at the end. All right, so in box A there was 2 red and 2 blue. Oh, green, sorry, no, that was box B, sorry. In box A there were 2 red and 2 green, and in box B there was 1 red and 3 green. So let's just go across here and say that in box B, it was 1 red and 3 green. Yeah, I got it right. Okay, so in each box, there were 4 counters. There's 3 red. There are 8 possibilities altogether. So when I'm finding probability, like it says, if box A is chosen, well, that's kind of a given. Okay, so it's chosen. I don't take it into account anymore. It is chosen. What's the probability that a red counter will come from it? Well, that's 2 out of 4, or a half. And if box B is chosen, what's the probability that a red counter is chosen? And that's 1 out of 4. Okay, here comes the harder part. The representation of options. This says tree diagram, and I'm going to do a tree diagram here, but we've already done a two-way table. That's what this is called, when 2 things are happening. And it talks about, you know, the probability of selecting box B and a red counter. Okay, box B and a red is right here. So for D, the probability of box B and a red counter is 1 out of 8. And then it says, what's the probability of selecting a red counter? Okay, well, just red is 3, so that's 3 out of 8. Okay, all the reds in A or in B, 3 out of 8. Let's just look at a tree diagram quickly. The tree diagram goes like this. It's, you know, kind of like a factorizing tree, and it puts the picks that you have. So we're going to pick the box in the first tree. So I could pick A or I could pick B. And in the second pick, it picks the counter. So for A and B, I could pick red and green. Here I could pick red and green. And on these branches, you can put the probabilities. So on branches, list probability. Okay, on branches, list probability. So I have a 50-50 chance here, so half and a half. And I know these things. When I'm in box A, I have a 50-50 chance of getting red or green because there's the same number of each. And when I'm in box B, I have 1/4 of red and 3/4 of green. And if I multiply across, I can tell what the probability, okay, the probability of getting box A and a red. That's a half times a half. Remember, fractions multiply across the top, multiply across the bottom. And the probability here of getting box A and a green is a half times a half, or 1/4. And the probability here of getting a blue, box B, I'm sorry, and a red is 1/2 times 1/4. So 1 times 1 over 2 times 4. And the probability here of getting box B and a green is that times that. 1 times 3, 2 times 4. And if I add these all up, you know, they should add up to 1 because this experiment is probability and it always adds to 1. So I could go 1 divided by 4 plus 1 divided by 4 plus, I hope I'm doing that right, 1 divided by 8 plus 3 divided by 8. And I get 1. So that's good. That's a good check, that these sum to 1. I've checked it out, okay? And that tree diagram is really going to help us. We'll do it on the next one, next video.